Question 13. Centrifugal pump is used in domestic water system, delivers water at 500 GPM and a head of 80 feet. The pump has an efficiency of 65% and the motor efficiency of 85%. The cost of electricity is 10 cents per kilowatt hour. This pump operates Monday to Friday from 6 a.m. to 10 p.m. What is an annual electricity cost to operate this pump? In order to solve this problem, type in brake horsepower or water horsepower, and you're going to get this formula. Brake horsepower equals to GPM multiplied by head multiplied by specific gravity over 3,960 multiplied by pump efficiency. In this case, since it's water, specific gravity is 1. So our GPM is 500 multiplied by 80 foot of head divided by 3,960, and our pump efficiency is 65%, which is 0.65. Now we get a brake horsepower of 15.54. In order to find electrical horsepower, it equals to brake horsepower divided by efficiency of our motor. So in this case, it's 54 horsepower divided by efficiency of our motor, which is 85%. This gives us total electrical consumption for this motor of 18.27. So now we have to calculate our kilowatt hours for the year. In order to do this, we take our electrical consumption horsepower. If you refer back to the engineering units in the beginning of the book, 1 horsepower equals to 0.746 kilowatts. We know that our motor operates 16 hours per day. It operates 5 days per week. And we know that 1 year has 52 weeks. So days cancel out, weeks cancel out, and we get hours per year. Now we know that our electricity cost is 10 cents per kilowatt hour. So now our kilowatts and now our hours cancel out, and we're left with dollars per year, which give us an annual operating cost. So in this case, if you multiply everything out, it's going to give you $5,670 per year. And this is our final operating cost for this pump.